So for our next example, we have this equation. And what I want you to notice about this equation is that you have all three variables being squared. So x squared, y squared, and z squared. They're all present, and they're all positive. Okay, and so let's write that down. So all x squared, y squared, and z squared are present and positive. And when you see that, you know that this graph is going to be some kind of what I'm going to call an ellipsoid. And so it's going to be sort of a sphere that's been squished in some direction. So that's what an ellipsoid is. It's like a elliptical type sphere. And so this one, I pretty much, I mean, it's put in standard form. You can see it. This guy is centered at 0, 0, 0. We can say that. We can say that the stretch factors, you're going to stretch along the x-axis 2, y-axis 1, z-axis 1. So let's go ahead and say that x-axis we're going to stretch 2, and then the rest are going to be 1. So we can go ahead and graph that. I'm going to use a different color. Let's use something fun. I really like that color. So let's do 1, 2, 1, 2, 1, 1, 1, 1. So this is going to be a little bit small, but you can already see what's happening. Let's cut a couple of traces, though, just to confirm everything is working how we think it should. So let's do, let's see, let's set, for example, x equal to 0. And when we do that, x equals 0, then we get this equation. So I get x squared plus, whoops, I'm getting kind of messy here. Let me try again. I'm getting, whoa, x squared plus z squared equals 1. That's just the unit circle. So the trace when x is 0 is the unit circle, and I'm going to really struggle to make this look nice, but that's the idea. We could do a similar trace we could do when y equals 0. And so we get x squared over 4 plus z squared equals 1. So when y equals 0, we're getting an ellipse that direction, and you know you're stretching it along x2 and z1, and so we can graph that if we want to. And I think at this point, for these kind of graphs, hopefully you've got the picture clear enough in your head. It's going to look like that, and then as you slice it this way, you're getting various circles. So that's not a very impressive looking graph, but it's going to have to do the job. Let's switch to Mathematica, though, and get a better looking picture, and then look at the traces there as well. All right, so I've got a graph of the sphere. This is looking at it from the standard orientation that we would think about it. And you can see that stretch a little bit more along the x-axis. And it's kind of a cool graph, really. The particular function that I'm using in Mathematica tends to make it a little less smooth. I don't know if you can see, but there's some funny here. There's like almost a line there instead of a round. That should be a complete circle, but the graphing software is struggling just a little bit. There are ways that you can make it look better, but that's good enough for us. So I wanted to do the traces with you just to help make it very clear. This first trace is when I'm fixing y. I don't know why, but I fix y first every time. So if you go out too far with y, too negative on y, then there's no trace, it doesn't intersect. You bring it in, then you begin to intersect here. Let's make this bigger. You begin to intersect the plane, y equals whatever, intersects the ellipsoid as a ellipse. And so you can see it that way. There's sort of this maximal ellipse, and then they get smaller and smaller and smaller, and then the traces disappear. So now let's do it where we can fix x. And so unfortunately, our orientation, the way we're looking at this is a little different than we're used to, but you can see it. If x is too negative, then there's no intersection, and then as you bring x up from being negative to positive, all of a sudden you just get these circles. They're perfect circle slices. So from this perspective, it's perfect circles. From the other way that we sliced it, you got ellipses. And so that's slicing in the x direction, and if you want to slice it in the z direction, then you can already tell you're going to get ellipses, and I guess I've already got one on the screen, but we'll go down to negative z, no intersection. When you bring it up enough, then you begin to intersect as ellipses again. And so even though it's difficult to graph the ellipsoid by hand, the traces, when you graph the traces, you can get a really good sense of what the 3D graph looks like just by graphing these two-dimensional traces and paying attention to how they fit together. So let's end this video here, and then we'll do another example in the next one.